Hello there. Welcome to Effective Mind Control. Think of this. You can identify one of the millions of images you have seen in just half a second. Could you have done that if such images were not stored in your memory? Could you have spotted them, without recognizing them? Where are such images stored? How are they recognized? Science lacks even a hypothesis about this mystery. But for science, combinatorial memories can be infinite. Elimination algorithms identify patterns in such memories in milliseconds. For Abraham Thomas, an engineer, intuition is such pattern recognition. Every act of the human mind results from pattern recognition. Human creativity depends on it. Human genius derives from it. Consciousness is powered by it. Fear and anger are unleashed by it. Without intuitive pattern recognition, there would be no civilization. Only stones and ice would exist today. Is intuitive pattern recognition meaningless? Abraham Thomas realized that the brain is powered by intuition. Intuition is a pattern recognition algorithm, which follows a logical path. Intuition enables the effective utilization of the massive human memories. Intuition yields answers to existential problems in 20 milliseconds. This video explains the important role played by the hippocampus in the recording and extraction of human memories. Surgical destruction of the hippocampus caused Henry Gustav Malazan to lose his ability to remember events, which occurred even a few seconds earlier. But he retained memories for events long past. While it is not the primary store of human memory, the hippocampus plays a crucial role in the consolidation of memories in extensive regions of the cortex. The hippocampus also supports a working memory, which enables the post-perceptual processing of information by the prefrontal regions. The hippocampus is a major component of the limbic system in the brains of humans and other vertebrates. Like the cerebral cortex, with which it is closely associated, it is a paired structure, with mirror image halves in the left and right sides of the brain. In humans and other primates, the hippocampus is located inside the medial temporal lobe, beneath the cortical surface. It resembles the folded back forelimbs and webbed feet of the classical hippocampus, a sea monster with a horse's forequarters and a fish's tail. The physical and mental experiences of the mind are stored as combinatorial memories stored in axon hillocks. Intuition extracts this data. With implicit memory, intuition confirms the existence of the data. Intuition extracts a small portion of this memory for conscious recall. Most people can indicate familiarity, implicit memory, with trillions of seen images, without being able to recall them, declarative memory. Amnesic patients show implicit memory for experiences, while lacking a conscious knowledge of them. They may guess which of two faces they saw most recently, while claiming not to have seen them at all. Intuition extracts procedural memories which enable a person to play a musical instrument, or to ride a bike. Such memories cannot be consciously recalled. Such memories are assembled without the assistance of the hippocampus. The organ records memories of significant experiences of the mind in the sensory and recognition regions of the cortex, while providing strong space/time bookmarks for the recall of such memories. The organ recirculates the transient perceptions of the immediate past to the prefrontal regions for its current valuation. This becomes a working memory, which protects the system from distraction and emotional reactivity and ensures quick and considered decisions and action plans. The earliest role of the hippocampus was to remember the position of an animal in space and to enable it to find the path to a hidden goal. The organ helps to find shortcuts and new routes between familiar places. As an example, London's taxi drivers are required by law to know the most direct routes between numerous places in the city. A study revealed that the relevant regions of the hippocampus were larger in these drivers than in the general public. The organ also had larger volumes in more experienced drivers. Remembered mental functions prove the presence of human memory. The stored memory's combinatorial patterns in the arrays of their receiving dendrites enable nerve cell recognition. Such memories were discovered to be applied by the olfactory sense, Nobel Prize 2004, for the instant identification of odors. A person who remembers a number during calculation recalls a working memory. The motor systems in one who rides a bike recall procedural memories. A person who recalls an event from the past uses his episodic memory. The hippocampus uses its spatial navigation competence to provide context for converting implicit memories into episodic memories, which can be consciously recalled after months and years. Damage to the hippocampus causes a loss of the ability to acquire such memories. The nervous system constantly monitors its current location. The hippocampus uses eye movement and head direction data as an inertial compass to chart geographic movement and position. Visual and sound information triangulate the location. These eye and ear coordinates are mapped by head direction cells, grid cells, and border cells in the entrinal cortex and the closely linked hippocampus. These regions were discovered to contain a neural map of the spatial environment in rats. Place cells are typically almost silent when a rat is moving around outside the place field, but fire faster when a rat reaches a place represented by the cell. The time dimension combinatorial pattern of firing by the place cells in the hippocampus trace the directions, objectives and movements of an individual in his environment. Mammals and birds enjoy long periods of dreamless slow-wave sleep, SW, followed by short periods of rapid eye movement dreaming sleep, REM. Siddhartha Ribeiro suggests that the wake-sleep cycle promotes propagation of memories outwards from the early coding sites. Neuronal reverberation is strongest during SW sleep. The correlations increase progressively during SW sleep, strengthening the memory trace. SW sleep shortly after memory acquisition is critical for memory consolidation. Sustained experience-dependent neuronal reverberation can be detected in several cortical areas up to 48 hours after exposure to novel experiences. Lack of such SW sleep causes an irreversible loss of the recently acquired implicit memory. A significant consolidation of memory takes place during REM sleep. Nature has provided a mechanism to replay the space/time context through rapid eye movements during sleep, causing persistent neuronal reverberation in the cortex, hippocampus, putamen, and thalamus. Incremental learning continues several nights after memory acquisition due to the progressive recruitment of larger neuronal networks over time. The hippocampus also has mechanisms which progressively disengage the organ from its older memory consolidation processes. Neuronal reverberation takes place in both SW and REM sleep. But, the physical movements of the eye distinguish the REM sleep process, critical to the learning experience. The added neural firing by the eye muscles may contribute to access, or store, data by identifying its space/time context. Subconscious eye movements often accompany search processes of the mind, say, the preparation of a shopping list. The eye movements may enable REM sleep to achieve greater knowledge consolidation in less time than SW sleep. During REM sleep, the hippocampus replays the space and time context of significant waking experiences. LTP circuits within the organ increase synaptic strength for such links. Neuronal reverberation, where linked nerve cells fire in rhythm, record the combinatorial patterns in all the linked groups of cells. Over many sleep/wake cycles, the organ spreads associative learning to extensive regions of the nervous system. With damage to the hippocampus, the nervous system loses its ability to bookmark, store and consolidate its episodic memories. Thank you very much for watching this effective mind control video. When you view the brain as a pattern recognition machine, many ancient mysteries vanish. Do come back to this channel. See you next time.